So imagine waking up tomorrow and seeing this headline everywhere. NASA confirms Mars once had rivers, lakes, and possibly oceans of liquid water. At first, it sounds like science fiction, but the truth is far more incredible because this is not a theory anymore. This is based on decades of real NASA missions, satellite images, robotic explorers, chemical analysis, and geological proof. And when all of this evidence is combined, it reveals one of the most shocking stories in space exploration. Mars was once a living world. When we look at Mars today, we see a frozen, dry, dusty planet. Temperatures drop below minus 80 degrees Fahrenheit. The atmosphere is thin. Liquid water cannot survive on the surface. But billions of years ago, Mars looked nothing like this. In fact, early Mars may have looked surprisingly similar to Earth. It had a thicker atmosphere, a warmer climate, rainfall, flowing rivers, massive lakes, and possibly even vast oceans. So what happened? And how do we know all of this is real? To understand the truth, we must go back more than 50 years, to the very beginning of Mars exploration. In 1965, NASA's Mariner 4 spacecraft became the first mission to successfully fly past Mars and send back close-up images. Scientists expected to see something like Earth, clouds, water, maybe even vegetation. But instead, the images revealed a barren, crater-covered world. At first glance, Mars looked dead. But there was a problem. Some surface features did not match that story. Even in those early images, scientists noticed strange patterns. Long channels, curved valleys, and eroded landscapes that looked suspiciously familiar. They looked exactly like dry riverbeds on Earth. But scientists were cautious. Maybe these shapes were carved by lava, maybe by wind, or maybe by something completely unknown. So the mystery remained unsolved. Everything changed in the 1970s with the arrival of NASA's Viking missions. In 1976, Viking 1 and Viking 2 became the first spacecraft to successfully land on Mars. They sent back thousands of high-resolution images. And what scientists saw shocked them. Mars was covered in massive valley networks, deep channels, floodplains, and delta-like structures. Some of these channels were hundreds of miles long. On Earth, such formations can only be created by flowing liquid water. Not lava, not wind, not carbon dioxide ice, but only water. One particular region called Valles Marineris stretched over 2,500 miles. Longer than the entire United States. Inside it were massive canyons, showing signs of water erosion. Another region, called Ares Vallis, looked like a dried river delta. Exactly like what rivers create when they flow into oceans. This was the first strong evidence that liquid water once shaped Mars. But there was a bigger surprise waiting. In the late 1990s, NASA launched the Mars Global Surveyor. This spacecraft mapped the entire planet in extraordinary detail. What it discovered changed everything. Scientists found ancient shorelines. Yes, actual coastlines. Massive curved boundaries that looked exactly like the edges of ancient oceans on Earth. These shorelines suggested that nearly 1/3 of Mars may once have been covered by a giant ocean. They named it the Arabia Ocean. If this ocean existed, it would have held more water than Earth's Arctic Ocean today. And suddenly, Mars transformed in our minds. From a dead rock into a planet that once had seas, storms, rainfall, and rivers. But images alone were not enough. NASA needed chemical proof, and that proof came soon after. In 2001, NASA sent the Mars Odyssey orbiter, equipped with special detectors to look beneath the surface. It discovered vast amounts of hydrogen locked in the soil, especially near the polar regions. Since hydrogen strongly indicates water, scientists concluded that huge quantities of frozen water ice lie just beneath the Martian surface. Some regions contained enough water to fill entire oceans if melted. Then, in 2008, NASA's Phoenix lander made history. For the first time, a robotic arm dug into Martian soil and exposed actual water ice. When sunlight hit it, the ice slowly sublimated, turning directly into vapor. This was direct physical proof that water still exists on Mars today. But the biggest discoveries were still to come. In 2012, NASA's Curiosity rover landed inside Gale Crater, a massive ancient basin. This crater once held a giant lake. As Curiosity climbed Mount Sharp inside the crater, it discovered layered sedimentary rocks, the kind formed only in long-lasting bodies of water. Then came the breakthrough moment. Curiosity drilled into a rock sample and found clay minerals. sulfur compounds, nitrogen, carbon, hydrogen, oxygen, phosphorus. These are the key ingredients for life. This meant that ancient Mars not only had water, it had habitable environments, lakes that lasted millions of years, freshwater chemistry, energy sources, and stable conditions. In other words, Mars had everything needed to support microbial life. But did life actually exist? That question remains unanswered. Yet another mission soon brought us even closer. In 2021, NASA landed the Perseverance rover inside Jezero Crater, an ancient river delta. This crater once held a massive lake fed by multiple rivers. Perseverance discovered stunning evidence of ancient river channels, flood deposits, and mineral formations that only form in water. But the most shocking discovery came in 2023. NASA announced that Perseverance had found organic molecules preserved inside Martian rocks. Organic molecules are the chemical building blocks of life. While this does not prove life existed, it proves that Mars had chemistry suitable for biology. And the story becomes even more mind-blowing. In 2018, scientists using radar instruments aboard the Mars Express spacecraft detected what appeared to be a liquid water lake buried beneath the South Polar ice cap. This lake is about 12 miles wide and remains liquid due to underground heat and salt content. This would be the first confirmed liquid water body currently existing on Mars. If true, it means Mars still has active liquid water environments today. And where there is liquid water, there is potential for life. So now we face the ultimate question. What happened to all that water? How did Mars go from a warm, wet planet to the frozen desert we see today? The answer lies in planetary death. Billions of years ago, Mars lost its magnetic field. Without it, solar winds stripped away its atmosphere. As the atmosphere thinned, temperatures dropped, water evaporated into space or froze underground. Rivers dried, oceans vanished. The planet slowly died. Mars became what scientists call a planetary fossil, a frozen snapshot of early planetary evolution. But this tragic ending may also hide a miracle. Because underground, protected from radiation, ancient microbes could still survive. NASA's future missions aim to drill deep beneath the surface and bring Martian samples back to Earth. And if even a single fossilized microbe is found, it will become the greatest discovery in human history. Proof that we are not alone. So next time you look up at that tiny red dot in the sky, remember, you are not just looking at a planet. You are looking at a lost world. A world that once had rivers, rain, storms, lakes, oceans, and possibly life. Mars is not just our neighbor. It is a mirror of Earth's possible future, and a reminder that even entire planets can die. If Mars once lived, could Earth face the same fate? That question may define the future of humanity. And now, as we move deeper into this mystery, one terrifying question remains. If Mars once had so much water, a thick atmosphere, and perfect conditions for life, why did it all disappear? To answer this, we must travel back nearly 4 billion years into the past, to a time when the solar system itself was young and violent. Early Mars was very different from the planet we see today. Its core was hot and molten. This created a strong magnetic field, just like Earth has today. This magnetic field protected Mars from deadly solar radiation and violent solar winds coming from the sun. Because of this protection, Mars was able to hold on to its atmosphere. With a thick atmosphere, Mars could trap heat. With heat, water stayed liquid. With liquid water, rivers formed, rain fell, and oceans existed. Mars was alive, but slowly, everything began to change. Over time, Mars started cooling from the inside. Its core slowly solidified. As this happened, the magnetic field weakened, and eventually, it shut down completely. This was the moment Mars signed its death sentence. Without a magnetic shield, the solar wind began stripping away the Martian atmosphere molecule by molecule. NASA's MAVEN mission later confirmed this exact process. MAVEN observed the solar wind literally blowing the Martian atmosphere into space. Over millions of years, the atmosphere thinned, pressure dropped, temperature collapsed. Water could no longer remain liquid. The oceans evaporated, rivers dried, rain stopped falling, and Mars slowly transformed into a frozen desert. But something incredible happened during this collapse. Not all the water escaped. Huge amounts of it became trapped underground, locked inside rock layers, frozen beneath the soil, hidden beneath the polar ice caps. This means Mars still holds enormous underground water reserves. Some scientists believe Mars contains enough buried water to cover the entire planet in a global ocean hundreds of feet deep, which raises a shocking possibility. If life ever existed on Mars, it might still exist underground. On Earth, life thrives in the most extreme places imaginable. Deep underground, inside glaciers, near volcanic vents, in radioactive environments, in oxygen-free zones. So if microbes could survive there, why not on Mars? Especially underground, protected from radiation and extreme cold. BT deeply buried in Martian rock and ice. This possibility has pushed NASA and space agencies worldwide into one of the greatest scientific hunts in history: the search for life beyond Earth. NASA's Perseverance rover is not just exploring Mars. It is collecting samples, carefully drilling into ancient rocks, sealing them inside sterile titanium tubes, and storing them on the Martian surface. These samples will later be picked up by a future mission and returned to Earth. This will be the first time in history that humans bring pieces of Mars back to our planet. Inside these rocks may lie ancient fossils, chemical signatures of life, or even preserved microbial remains. And if that happens, everything changes. But NASA is not alone in this mission. China, Europe, and private space companies are all racing toward Mars. Because Mars is no longer just a science target. It is humanity's future backup home. Which leads us to the next shocking truth. Mars is not just about the past. It is about our survival. Earth is facing climate change, rising temperatures, melting ice caps, extreme weather, mass extinction, and resource depletion. Mars represents a second chance, a new world, a backup civilization, and possibly a new beginning. Elon Musk and SpaceX plan to send humans to Mars within the next decade. NASA's Artemis program aims to build lunar bases to prepare for Mars missions. Scientists are designing habitats, farming systems, oxygen generators, and water extraction technology, all based on Martian ice. In fact, NASA has already successfully produced oxygen from Martian air. This means future astronauts could breathe on Mars and drink water extracted from underground ice. Mars is no longer science fiction. It is becoming human reality. But survival on Mars depends on one thing: water. Water for drinking, water for farming, water for oxygen, water for fuel. And that is why NASA is obsessed with mapping every hidden ice deposit on Mars, every underground glacier, every frozen lake, every buried ocean. Because where there is water, there is hope. And now, the biggest mystery of all: was Mars destroyed naturally or artificially? Some scientists have raised a controversial idea. What if Mars once hosted a civilization? And what if something catastrophic wiped it out? There is no solid evidence for this, but certain anomalies keep raising eyebrows. Unusual nuclear isotope ratios, strange surface features, odd atmospheric chemistry, nothing conclusive. But just enough to make scientists curious. And that curiosity drives deeper exploration. Because if life arose independently on Mars, then life in the universe must be common. And that means our galaxy could be filled with living worlds, civilizations, intelligence, and maybe observers. Mars teaches us a powerful lesson. Even a planet with oceans, rivers, rain, and life can die. Which means Earth is not invincible. We must protect our world, because Mars shows us exactly what happens when a planet loses its balance. One day, humans will walk on Mars. They will stand on ancient lake beds, touch fossilized river rocks, drill into billion-year-old ice, and maybe discover that we were never alone. That life is not unique to Earth, that the universe itself is alive. And when that day comes, the story of Mars will become the story of humanity. A story of survival, exploration, discovery, and hope. So when you see Mars glowing red in the night sky, remember, you are not looking at a dead world. You are looking at a sleeping giant. A planet filled with history, secrets, and maybe life. And now, as we move even deeper into the mystery of Mars, we arrive at one of the most fascinating chapters of all: the hidden world beneath the surface. Because while the surface of Mars looks dead, frozen, and lifeless, what lies below may tell a completely different story. On Earth, life exists in places once thought impossible. Deep inside caves, beneath kilometers of ice, inside volcanic rock, and boiling acid lakes. Even in radioactive environments, scientists have found microbes living more than 3 kilometers underground, surviving without sunlight, oxygen, or organic food. They survive by feeding on chemical reactions inside rocks. This discovery completely changed our understanding of life. It proved that life does not need sunlight. It only needs energy, water, and chemistry. And when scientists applied this logic to Mars, a shocking realization emerged. If life ever started on Mars, it may still be alive underground. Beneath the cold surface of Mars, temperatures increase, pressure increases, and water ice can melt into liquid. Radar scans show vast underground reservoirs, frozen aquifers, and buried glaciers. Some scientists believe that deep underground, Mars may still have liquid water pockets. Protected from radiation, shielded from extreme cold, stable for millions of years, which creates the perfect hiding place for microbial life. This is why future Mars missions are being designed to drill deeper than ever before. Not just centimeters, not just meters, but tens of meters beneath the surface. Because that is where Mars may still be alive. One of the most ambitious upcoming missions is the Mars Sample Return Program. This mission will bring Martian rocks back to Earth. Not just any rocks, but the most ancient and scientifically valuable samples ever collected. Scientists will analyze them using the most powerful laboratories on Earth, searching for fossilized microbes, chemical fingerprints of life, complex organic molecules, and isotopic patterns that only biology can produce. If even a single biological signature is found, human history will change forever. Because that discovery would answer the most profound question ever asked. Are we alone in the universe? Now, let us imagine something even more extraordinary. What if Mars once had not just microbes, but complex life? Plants, animals, oceans filled with ecosystems, forests, rain cycles, cloud systems, entire biological worlds. This idea may sound extreme, but Earth itself went through similar phases. For nearly 3 billion years, Earth was dominated only by microbes. Complex life appeared very late, so if Mars lost its atmosphere early, its biological development may have been cut short. Life may have existed, but never had time to evolve into complexity. Mars may represent a frozen snapshot of early planetary life, and that makes Mars the greatest scientific treasure in the solar system, because it preserves planetary history in ways Earth cannot. On Earth, tectonic activity destroys ancient rocks. Erosion wipes away evidence, volcanoes reset landscapes. But Mars is geologically quiet. Its surface preserves billions of years of history. Every crater, every valley, every mineral layer is a time capsule waiting to be read. When we study Mars, we are not just studying another planet. We are studying our own past. Because early Earth and early Mars were remarkably similar. Same building materials, same formation process, same bombardment history, same solar radiation. Yet Earth survived. Mars did not. Which leads us to the ultimate lesson Mars teaches us. Planetary survival is fragile. This process is known as terraforming, altering a planet's environment to make it habitable. Some scientists believe that one day, humans could thicken the Martian atmosphere, warm the planet, melt polar ice, restart water cycles, and bring back rivers, rain, clouds, and possibly oceans. Mars could be reborn, but this is not just engineering. This is planetary resurrection, bringing a dead world back to life. However, there is a moral question hidden inside this dream. If Mars already hosts life, do we have the right to change it? Do we risk contaminating an alien ecosystem, destroying a second genesis of life? Before we understand it, this ethical dilemma is one of the greatest debates in modern science. Preserve Mars or transform it. Study life or create life, protect or colonize. Mars is forcing humanity to face questions never before asked. Questions that define our role in the universe. Are we explorers, caretakers, or conquerors? And now, we reach perhaps the most mind-bending idea of all. What if Mars was not always dead? What if it was intentionally destroyed? Some scientists have noticed strange isotopic ratios in the Martian atmosphere. Unusual nuclear signatures, odd radiation patterns, certain chemical anomalies. These do not prove anything, but they raise questions. Questions that science cannot yet answer. There is no evidence of ancient civilizations, no ruins, no technology, no artifacts, but the universe is vast, and time is enormous. If a civilization existed billions of years ago, its traces may have long vanished. Mars remains silent, but its silence is haunting, because sometimes silence hides catastrophe. Which brings us to the final realization. Mars is not just a planet. It is a message, a cosmic warning, a reminder, a mirror, showing us our own possible future. If we destroy Earth's climate, if we collapse our atmosphere, if we disrupt planetary balance, Earth could slowly become another Mars. A frozen desert, a silent world, a lost civilization. But Mars also offers hope because it shows us that life can begin, that planets can evolve, that worlds can transform, and that humanity can become a multi-planet species. One day, children will be born on Mars. They will grow up under a pink sky, watching blue sunsets, playing in low gravity, calling two planets home. And when they look back at Earth, they will see a small blue star and realize life did not stay confined. It spread, it survived, it conquered the void. Mars is not the end of a story. It is the beginning of a new chapter for humanity, a chapter written across stars, across worlds, across time, and the greatest mystery still remains. If Mars once had life, where did it go? Did it die? Did it evolve? Or did it escape? Because the universe is vast, and sometimes the greatest discoveries lie not in answers, but in the questions themselves. This is Infinite Cosmos.